Okay, so we are back and we are going to continue now learning about compound interest now, more specifically, because like I said, that's the goal when you're trying to invest and save your money. You want it to grow exponentially. So you're searching for compound interest at a bank. But we're not going to be using a table, like I said, to fill in all the lines and carry the next number over to the next year. And it just becomes too much. So there is a formula. And the formula is your exponential growth formula. So you've already seen this formula when we did our exponent unit because compound interest grows exponentially. This is your exponential growth formula. So you know it as final amount equals initial amount, bracket 1 plus the rate to the exponent time. So you know it like that. We just changed the letters. So now they mean letters that refer to money. So A is the final amount, not interest, but total. So A is the accumulated total amount, which is sometimes called future value. So what the money will turn into in the future. P is your principal. So that's your starting amount, right? That goes here in the front. This is also called sometimes present value. So if you ever hear that word present value, think principal. It's the same thing. 1 is obviously 1, just the number 1, because it does the adding, right, on for us. So we don't have to do the table anymore and add it ourselves. This will do the adding for us on to the original amount. I is your interest rate. So in simple interest, it was R, but here it's little I, not capital I, but little I. And little I is the interest rate, again, always as a decimal, per visit. So depending on how the interest is being calculated will determine how much interest you get on that particular visit. And when I mean visit again, it's the bank manager visiting your account to give you interest. If it's done annually, that means you only get one visit a year. Annual means once. So that one time a year, you're going to get everything on that one shot. If it's done semi-annually, then you're going to get that interest cut into 2 equal portions. So we would then take that interest rate and divide it by 2 when we put it into this formula. You're going to see. It's really straightforward. N is the total number of visits that you're going to get. So total visits, which is basically how many visits you get a year times how many years you're going to put the money away for. So if I get 2 visits a year, for interest because it was compounded semi-annually, and I put the money away for 5 years. 5 times 2, 10. N would be 10. So let's look at this table that covers that a little more specifically. So we have little I and we have little n. These are based per visit. So I and n always have to be calculated. How much do you get on each visit? And that's going to depend on the question as to how it was broken down. These are the common ways that you can get compounded interest. So annually means 1 visit a year, right? Once per year. Semi-annually means twice a year, every 6 months. Quarterly means 4 times a year. So you think of it like 1 time a season, right? Every 3 months. Monthly, of course, there's 12 months in a year, so that means you're going to cut it into 12 equal portions. Bi-weekly means every other week. So weekly is 52 times a year. Every other week would be half of that, 26 times a year. So not this week, but next week. Then you skip a week, then the week after, that kind of thing. So that's also very common. So these are the more commonly ways. There might also be something called semi-monthly, which is 2 times a month, right? Which would mean 24 times a year. But that's not done as commonly. So what happens is we have to then take the little I that's in the question, the interest rate, and we have to divide it into these equal portions. So if it's compounded semi-annually, I'm going to take the interest and divide it by 2. If it's compounded quarterly, I get 4 visits a year. That interest is for the entire year. So they're not going to be generous and give me that same percent 4 times. What they're going to do is they're going to cut it into 4 equal portions. Same thing with monthly. You're going to divide your I by 12, bi-weekly divide it by 26, and weekly divide it by 52. Now with N, again, you're thinking of the total number of visits. So you're going to take the number of years, so your years, and you're going to times it by 2 if it's compounded semiannually, because I got 2 visits each of those years. If it's quarterly, you're going to take the number of years and you're going to times it by 4. If it's monthly, you're going to take the number of years you're putting the money away for and you're going to times it by 12 because you got 1 visit each month. So hopefully you're seeing the pattern here. Years times 52 if you're looking at weekly. So I think the easiest way to do it is just to jump in. You have the table here to refer back to. Determine how much money you will have. Okay, so we're looking for the future. If you invest $500, so we're looking for the future, we're going to put away $500. So that's principal. At 4% for 6 years, compounded semi-annually. So now you see the word compounded. So it's not that I equals PRT stuff anymore. That was only for simple interest. Compounded means you're going to be using this formula and only this formula. We're not going to do a table either. So we're going to use that formula, A equals P bracket, so times 1 plus I to the exponent n. A is what we're looking for. P was the original amount, $500. 1 is just 1. I is the interest rate, but semi-annually, so cut into 2 equal portions. I'm getting 2 visits a year. So 0.04, right, that's 4%. But we're going to have to divide that by 2. So right now, don't write down what that decimal is, what the answer is. Just keep it like that for now. Let the calculator do all the work. N is 6 years, right? I'm saying goodbye to my money for 6 years. But I got 2 visits each of those 6 years. So how many total visits did I get here? Well, obviously 12, right? So I take my years and I times them by 2. Okay, so semi-annually told me I was doing this. Now we go back to the formula. A equals 500 bracket 1 plus 0.04 on top of a 2 to the power of 12. Now we can do this all in one step in our calculator. So in your basic calculator, start with the 0.04 divided by 2. Whatever you get as a decimal, just leave it there. Plus 1 equals exponents, right? Before you multiply, you do exponent. So your exponent of 12 equals, keep all those numbers, times 500 in the front. 634.12. 634.12. Right? Money always has 2 decimal places. So it took 6 years for your $500 to become $634. That's really slow. That wasn't very good. You only made an extra $134, right, on your investment. So not the best growth there. Let's try another one. Amy borrows $5,000 to buy a car. So that's her original amount. She agrees to pay it back in 4 years. So that's her time. The interest on her loan is 6.5%. Compounded quarterly. So compounded, we know the formula then we're going to use is this. And quarterly is important because it tells us what we're multiplying or dividing by. How much will she have to repay at the end of the 4 years? And how much of it was actually interest? So again, A equals, P equals, I equals, N equals. Do we know the future amount she's going to have to pay back? No, that's what the question's asking us. Do we know the original amount? Yes, $5,000. Do we know the interest? 6.5%. And it's going to be divided into 4 equal portions. So remember, convert percents to a decimal, divide by 100, 0.065. I'm going to keep it on top of a 4 because it was compounded quarterly. So we divide by 4. Quarterly, 4 times a year. And how many years? Well, it says it's going to take her 4 years to pay it back. But she gets 4 visits for interest each of those 4 years. Because again, it's quarterly. 4 times 4, 16. Put all of this into the formula as is. Start from the inside out. 0.065 divide 4 equals. Don't write it down. Go plus 1 equals. Exponent 16 equals. And then times 5 grand. $6,471.11 is what she will have to pay back at the end of the 4 years. That's total, right? It has the 5,000 in there. If you're interested in how much of it was interest, right? So final amount minus principal. What is 6471.11 minus out the 5 grand? Because she had to pay back the 5,000 regardless. The extra money is the 1471.11, right? This minus this. That's how much the bank made off of her. That's how much extra money she has to pay back at the end of the 4 years. All right, last one here. Jamal invests $3,000 into a GIC. GIC is a guaranteed investment certificate, so it's something you can invest in. That pays 2.4% compounded monthly for 10 years. So he's not allowed to touch his money for 10 years. How much will he have at the end of the 10 years is what we're interested in. So again, compounded means we're using this formula, right? Exponential growth. Future amount, we don't know. Original amount was 3,000 in this case. Little I was 2.4%, but we're going to divide it into monthly chunks. So we're going to divide it by 12. So divide this by 100, right? Jump once, jump twice, and still have it over the 12. Don't divide it here, leave it into the formula. N, 10 years. Has to say goodbye to his money for 10 years. But he got 12 visits each of those 10 years, right? Monthly. So 12 visits for 10 years is 120 total visits. So plug all that into the calculator. 1 plus 0.024 on top of a 12 to the exponent 120. So let's see 10 years what $3,000 will turn into. 0.024 divided by 12. So 0.002 is what we have here. Add 1. Exponent 120 times 3,000. $3,812.83. 38,1283. Look at that final amount. Do you think that was a good investment for him? It took him 10 years to make an extra $812. That wasn't good at all. And the reason for that is that typically GICs pay very, very low interest. This isn't a lot of interest. So he did give the money away for a long time, so he should have actually earned a lot more, but he would have needed to put it into a better product because 2.4% is actually very low. So just to keep that in mind, time is great, but there's no point in wasting 10 years if you're not earning a good interest rate. So that will definitely take you through 8.3. You have the table, so you've seen monthly, you've seen quarterly, semi-annually, but just in case you see weekly or bi-weekly, you just follow the table and do what it says. Pretty straightforward. And you're going to find your practice in the 8.3 section of the practice book. All right, so let me know if you have any questions.